This is Carly Schrader, and welcome to my presentation on infiltration and runoff and erosion bottles. So, I did some background and defined infiltration and runoff to increase my understanding. You can read those definitions there. And I just recorded some of my takeaways from the simulation that I interacted with. It was interesting to find clay soil, which is what's in our yards on the top most often around here, has less infiltration than more loamy sandy soils, and forest, grassland, and wetland had the most infiltration but the least runoff. Surprisingly though, wetland stayed the same across the types of the soil. Using the NGSS standards for 4th grade, this activity aligns with the standards you see below, because for the first one, it really aligns with a conversation about flooding and how to reduce flooding, and the second one to relate it to erosion. So connections among STEM practices. For technology, the simulation is a new technology that helps us better understand the situation prior to our investigation. We define the problem, we ask questions about what type of soil and land cover would be the best for the healthiest watershed. We planned and carried out the investigations by creating the erosion bottles and what type and what things we were choosing to put in the bottles. We analyzed the data of what did the sample look like, both in the cup of runoff and in the bottle. Constructed explanations as to why it occurred, and thought about the best solution to the watershed problem. And now we are communicating that information through our slideshows. So I started off by testing the difference between potting soil and clay for runoff and infiltration. So I took the clay from my yard, and as you can see from the cups, clay clearly had more runoff. They're both dirty, so they both had a lot of erosion. When you compare the bottle pictures, clay had way more pooling and less infiltration than the potting soil did. So, thinking potting soil performed better, I tested it across several land covers. So grass that I grew from seed in a week, mulch, moss I collected from my yard, rocks from my garden. And if you notice from the cups and the bottle comparison that grass had the lowest amount of runoff, mulch still had dry soil and the cleanest water, which shows that it had the highest infiltration, which is probably due to the fact that my grass is rarely young and has less roots than more grown-up grass might have. I showed in the rocks picture that water pooled at the front, but not as much in the back, but the rock and the moss had a lot more water pooling than the mulch and the grass, showing that they had less infiltration. So I improved it by also still testing the clay across land covers because I was intrigued by the results from the potting soil and wanted to compare. So the only difference is the grass was transplanted from my yard, so it was more grown-up grass. All showed up much cleaner than the potting soil, but way more pooling immediately on into runoff, so way less infiltration. But the grass and the mulch are the cleanest, showing the least erosion amongst these samples. So my takeaways when comparing across land covers and soils is more infiltration equals less runoff. Grass in both soils had the smallest amount of runoff. Mulch reduced erosion. Transplanted grass ran the clearest, least equals the least erosion. Clay had less erosion than potting soil, but also less infiltration shown by immediate pooling and more runoff. The goal would be the highest infiltration and lowest runoff and the least amount of erosion to be able to help the watersheds and to help flooding trouble. So what I'd want to test is fully grown grass in potting soil. So by doing that, I'd hope to see that there would be less erosion in addition to higher infiltration and lower runoff than seen with the grass that was grown in the clay soil. So that wasn't really possible in the winter conditions, but it'd be something to try. So I look forward to seeing your all work too.